Good evening. Today we will look at the chapter on laboratory and sampling of the Food Safety and Standards Act of India and the Food Safety and Standards Rules and Regulations 2011. So if you look at the chapters, this is the very last chapter, laboratory and sampling analysis. So what are the types of laboratories that there are for testing? There are 5 different types of laboratories if we can classify them. One is the in-house laboratory or the industry laboratory, which is in the premises of the food business operator or the food processor. And if you recollect, all oil food business operators who do refining of oil or producing oil must have a laboratory in their premises. So most of the big players in the food industry have their own laboratories, and they are mainly for due diligence to see that the products, the quality control of their products. Then you have the government laboratories, as you will see, which are the state laboratories. They are either the public health laboratories, called the public health laboratories, or they are called the state food laboratories. And we have the national referral labs. The state food laboratories and the national referral labs are mainly to ensure the health of the consumer and also to protect the consumer from any illnesses, foodborne illnesses, or any unsafe causes of the food. Then you have the independent testing laboratories, which are the contract testing laboratories. They also do food analysis, pharmaceutical analysis, cosmetic analysis, and all this. And this is a business, and they offer their services, and it is for commercial value. Then you have the university and research laboratories, where most of the laboratories, even if the analysis is done, they are mainly for R&D purposes or to develop methods and validate methods. And lastly, we have what are the mobile food testing laboratories, which are laboratories on wheels, which are capable of moving to different parts of the country or the state and carrying out the testing of the samples. And here the testing is mainly a qualitative testing because you cannot keep very many instruments in these mobile food testing laboratories due to the condition of our roads and the paths that there are. So these are the 5 different types of food testing laboratories. As per FSSAI and Annexure 3 of the Food Safety and Standards Licensing and Registration of Food Business, it says that all the food business operators shall ensure testing of their products, relevant chemical and or microbiological contaminants in food products in accordance with the regulations as frequently as required on the basis of the historical data and risk assessment, which not many of them carry out. And this is to ensure production and delivery of safe food to the consumer. It can be through their own laboratories or through the commercial laboratories or through the FSSAI noted laboratories. And they must have a test report or a certificate of analysis of their food product at least once in 6 months. The laboratories where they get their testing done must be accredited to the ISO 17025-2017 through the National Accreditation Board of Calibration Laboratories, which is now under the Quality Council of India. So this rule has been laid down in the licensing and registration of food businesses chapter. So therefore, the laboratories play a very important role. So if you look at the organization of the laboratories which come under FSSAI, or rather which carry out food testing for the Food Safety of Standards and Standards Authority of India, are the state public food laboratories or the state public health laboratories. Each of these laboratories function under their own state or union territory, and they are utilized primarily for the first analysis of the sample uh, carried out by the food analyst. So anytime you have seen a food safety officer picks up the sample, the first sample goes to the state public food or the state laboratory. And then you have the referral laboratories, which are notified by FSSAI, and these are for the purpose of referral testing according to our rules and regulations. And in a short while, we will see when the food is tested by the state public laboratory and when it goes to the referral laboratory. These referral laboratories, they only carry out the testing for FSSAI, but they come under various ministries and departments such as the Indian Council of Agricultural Research, the Council of Scientific and Industrial Research, CSIR, and also ICMR and DBT or DST. Many of these laboratories, the referral laboratories, are divided region-wise, and some of them are particular or for a commodity. And then we have the third group of laboratories, which are the commercial laboratories. And these commercial laboratories are recognized by FSSAI and notified. Their role in the regulation procedure is they carry out the primary analysis of the sample if the FBO requests and the FBO does not have faith in the state public health and wants it carried out. They are also utilized for carrying out the analysis of the imported food samples sent by the authorized officer, because there the results have to be given within 5 days to prevent the food business operator from getting the demurrage charges. So these are the three types of laboratories which the FSSAI actually uses. Under FSSAI, in the referral laboratories, two referral laboratories are directly or they are a part and parcel of FSSAI. We will see that. So first let us see what is the role of an analytical laboratory. If you recollect, the food safety officer will pick up the sample by paying the food business operator. This is if he suspects that it is in contravention to the rules and regulations. He divides it into 4 parts. So what is the role of the analytical laboratory? One part of the sample is first sent to the state health lab or to the state food lab. And if the FBO demands in writing in a particular form, then a second part will be sent to the FSSAI notified laboratory, which is an NABL accredited laboratory, and the FBO must pay the accredited laboratory the charges for the sample analysis. Now, in the sample analysis, when the reports are ready from the food analyst, and if it has gone to the NABL accredited lab, these reports go to the designated officer. So the reports are prepared in quadruplicate and they are sent to the DO. Now the DO looks at the analytical reports, and if he feels there is some contradiction between the results of the NABL lab and the state lab, or if he feels that he needs to get the sample analyzed again, the designated officer has the power to send the sample to the referral food laboratory for analysis. So you see, we have 4 parts of the sample. So a third part of the sample goes to the referral laboratory. The referral laboratory, being an apex laboratory for the analysis, will carry out the analysis and send the report to the designated officer. The report of the referral food laboratory is final. This cannot be contested by the FBO other than in court. So the referral laboratory has a very important and responsible role in the analysis of the sample. Also, the FBO can appeal against the food analyst's report, and then also the sample will go to the referral food laboratory. If the FBO does not appeal, then the designated officer takes a decision on whether he will penalize the FBO, or if the penalty will be decided. If the FBO appeals against the penalty or whatever the designated officer has imposed upon him, if he feels that he is right, then he goes through the legal procedure and he goes through adjudication. In the adjudication, the state government would have set up an adjudicating officer who is at the level of a magistrate, and there, just like how any other cases are tried, that will be tried. If the FBO appeals against the adjudication by the adjudication officer, then it goes to the tribunal special court and the case is tried and a decision is given. So there are many options. One, if he accepts the designated officer's penalty, it ends here. If he appeals against the food analyst's report, it goes to the referral food laboratory. He cannot contest the referral food laboratory's report. Then he makes an appeal and it goes for adjudication. And in adjudication, the state government will either launch the prosecution or the penalty if it is unsafe, substandard, or misbranded. The FBO can appeal against that in the tribunal, special court. Again, all these are appointed by the state food commissioner. FSSAI has no role. It only makes these regulations for the flow of the samples and the analysis of the samples. So you see, the referral laboratory is the final laboratory in giving the report, and the report of the referral laboratory cannot be contested by the FBO other than going to the adjudication or appealing in the tribunal special court. So when the case goes to the tribunal special court, or say the referral laboratory personnel must be ready to appear before the court if called for to provide any evidence. So therefore, the role of the referral food laboratory is very important. Very often, the food analysts from the state health laboratory are also called to court to present, to give evidence and even their notebooks are evaluated, are physical evidence that they have carried out the analysis. So therefore, being a food analyst and being a food analyst in the referral food laboratory are very responsible positions. And so those of you who are taking the food analyst exam and you get qualified as a food analyst, you are eligible to sign the reports. And once you sign the reports, you are held responsible for every action or every word that is written in the report, including the method, the sampling, the testing, and the opinion that you write in the report. So now if we look at the referral laboratories, as I said, the appeal against the report of the food analyst will lie with the designated officer, and he will decide whether to refer it to the food laboratory as notified to the referral food laboratory. So these are the referral food laboratories of our country. The first four that are shown in red are the region-wise laboratories. So we have in Karnataka, we have the referral food laboratory Mysore. In Maharashtra, we have the referral food laboratory Pune. In Uttar Pradesh, we have the Food Research and Standardization Laboratory, which is known as FRSL Ghaziabad, and West Bengal Referral Food Laboratory. These two laboratories belong to the Food Safety and Standards Authority of India, whereas this laboratory is under the Council of Scientific and Industrial Research, and this is under the territory of Pune. Now, as I said, some of the referral laboratories are commodity-wise. So for fruits and vegetables, you have the IIHR in Hesarghatta. For fruits and vegetables, again, you have the Indian Institute of Vegetable Research, Varanasi. For spices, we have the Spices Board Laboratory. We have the Quality Evaluation Laboratory in Guntur. And you see, across the country, we have referral laboratories. We have the National Research Center for Grapes, for pesticide residues. We have the National Research Center on Meat, for meat and meat products. We have the CAF, that is the Central Analysis Learning in Livestock for milk and milk products. So you see, for most of them are product specific. The CIFT is for fisheries. So we have several of these laboratories across the country. So what is the role of the referral laboratory? Other than the role to analyze the samples sent by the authorized officer or the designated officer. So the major or the main role is to analyze the samples of food sent by an officer or authority authorized by the food authorities for the purpose and submission of the certificate of analysis. They are also utilized for the investigation purpose for fixing the standards of any article of food. We discussed the standards of different food. We discussed the levels of additives to be added. So the referral laboratories are also used for this purpose. So whenever FSSAI wants some surveillance data, wants some data, they request the referral food laboratories to provide this data. They also, in collaboration with the laboratories, the food authority may approve them for the purpose of standardizing methods of analysis. For many products, we find that there are no methods which are involved. So the laboratory can be asked to standardize the method, or the laboratory can be asked to verify a method which has been published or validate a method which has been published. And these laboratories must ensure that they follow strictly laid down scientific protocols for handling and testing of the food. They have to maintain very high standards of accuracy, reliability, and credibility. and they have to all be third-party accredited by NABL. They are also used for laying down the mechanism for ensuring that all the analysts who work, they adhere to the highest professional standards. That means they maintain confidentiality and impartiality and any other conditions as the authority may lay down. But confidentiality and impartiality are the two most important criteria of the food analyst while carrying out the analysis. So this is a picture of a mobile food testing lab. So you see here is a big bus which has been converted into a laboratory. You have the big windows through which the samples can be received, and the equipment are placed on the working table. And when the van or the bus is ready to move, these equipment are placed in vibration-proof boxes before the mobile van is on the road. So some of the mobile vans are sophisticated, and all of them have got refrigerators, all of them have a regular water supply, and they have power which is given to the lab by generators placed within the mobile van. So when samples are sent to a regulatory laboratory, whether it is a state food health laboratory or the referral laboratory, there are key elements that must be practiced by the personnel of the regulatory laboratory. RL stands for regulatory laboratory. It could be the state lab, FSSAI notified lab, or the referral food laboratory. Among these, you see, very important is sample security. We must see that the sample is secure, the sample is stored securely, it cannot be meddled with or tampered with. So sample security is very important. The laboratory must be able to account for the sample from the day it arrives in the laboratory to when it is disposed. So every gram of the sample should be accountable for. Maintaining the sample integrity is very important. That means not allowing it to be adulterated, not allowing it to degrade, storing it at the correct temperature, storing it at the correct environment. That means if it says room temperature, so it must be in a refrigerator, in a room where the temperature is maintained at 25 plus or minus. And then we have maintaining the chain of custody, that is maintaining a document from when the sample arrived to when the sample was disposed, using the test methods, that means using international and the fit for purpose test methods, validating them or verifying them in your laboratory. The data that is produced from the testing must be safe. There should be no changes in the data, no crossing out, no coloring it or putting white ink. You're allowed only to cross it out. Data must be controlled and it must be retained very safely and securely so that there can be no tampering of the data. Then there has to be accurate data reporting. So all these constitute the key elements for best practice at a referral laboratory. And those of you who are going to become food analysts must follow all these elements. So how do you maintain security? So there are four integrated domains. One is you have physical or architectural security. So the laboratory can have doors, walls, fences, locks, barriers, controlled roof access, and cables and locks on the equipment and the rooms where you store the sample, etc. That is securing it physically. You can also have electronic security where you have access control systems by using the card access, or you use alarm systems, password protection, video surveillance. Now you have got biometrics. So only authorized people can enter the laboratory or the instrument room. The operational security is the security to show that the analyst has used the equipment for carrying out the analysis, and that is signing the sheets or the logbooks of the equipment after using, control of keys and access cards, authorization procedures. If A is authorized to make a change, only A should do that. B cannot do it. If A is authorized to receive the sample, C cannot receive the sample. Only A must receive the sample, and then there will be an alternate person in case he is on leave. So background checks and security guards also are required in the regulatory laboratories for operational security. And then for information security, you have passwords, backup systems, and shredding of sensitive information. So if you look at the flow chart of analysis of appellate food samples or the legal samples that are picked up by the food safety officer and sent to the laboratories either by the food safety officer or the designated officer, is it goes to the laboratories with the sample goes along with a memo which goes independently. The laboratory is responsible for documenting the sample received, the state of the sample received, the date it is received. Then they have the internal procedures as per ISO 17000 to carry out the analysis, and all these analytical parameters of the rules and regulations must be carried out. That is the labeling compliance, compliance to the food additives, those which are permitted or not permitted, the microbiology safety parameters, physical examination, quality parameters, pesticide and antibiotic residues, heavy metal analysis, and naturally occurring things. So what is indicated over here is all the testing that is done in the laboratory, and then writing the report according to the format and sending it to the designated officer. So this is the simple flow chart showing you how the sample enters the laboratory and the report goes to the designated officer. So what is chain of custody? So chain of custody is actually a chronological written record telling you when you acquired the sample until its final disposition, that is discarding it. And this assures continuous accountability. And if you see, one of the elements of success of a laboratory is accounting, the accountability. So if you have this chain of custody, it will add to the accountability. So this chain of custody is considered confidential and classified. It must be maintained in a secure location. Every lab can develop its own chain of custody form. You need not follow, there is no universal chain of custody form. The regulatory laboratory is responsible for retaining records regarding the sample. So why this chain of custody is maintained is because the laboratory samples are physical evidence. So you have to have evidence that the sample has reached the laboratory, and also you must have evidence that the sample has been analyzed. And so if a chain of custody is maintained, you can show this as physical evidence. So what is there in the chain of custody? The form will account for people who handle the sample. So who obtained it, who delivered it, who tested it, and who disposed it. So therefore now you see, from the time it arrives in the laboratory till it is disposed, you will have a record. And then the next question will be, when was it tested? When did it go to the next laboratory? When was it delivered to the microbiology laboratory? When was it tested in the microbiology laboratory? When was it disposed? And whoever signs this chain of custody may be called to testify in the court of law. So therefore, each person signing the form is responsible for the care and preservation of that sample while in their possession. It could be called a traceability form, it could be called a chain of custody, but the sample must be traceable and accounted for from the time it arrives till it is disposed. So most of the referral laboratories and state laboratories have got very stringent procedures, and they have a sample receipt register where they note down when the sample was received, when the memo was received, when the parcel was opened, and they give a code number, the laboratory code number to them. If you look at the testing has to be confidential, and the analyst should not be aware of where the sample came from, who the sample came from. They have to only do the testing. They are only aware that it is a wheat sample which has to be tested, or it is sauce which has to be tested. And for every document, the name and the signature of the person carrying out that activity is very important. So we have seen this. So the sample package from the designated officer comes with and as per the regulations, where you have the code, you have the securing thread, you have the signature of the person sending it, the DO or the FSO, the seals, and the paper it is wrapped in. And the laboratory gives their own reference number. And then when the parcel is opened, after the laboratory number gives its number, this is all to maintain the security and the integrity and accountability of the sample. So laboratories do give different numbers so that the analyst only analyzes as per the number, not from where the sample has come. So during this also, if you look, laboratories are very careful when the sample comes, and they also carry out what is known as trying to match the seal of the sample outside with the seal that comes in the memo. So this clearly shows that when the sample has left the designated officer's room to when the sample has been received in the laboratory, there is no tampering. So the seal remains the same. And each food safety officer or each designated officer has got a unique seal. This seal, the impression of the seal, is not common to the food safety officers and designated officers. The laboratories also make sure that when they receive the sample, they have got the samples which are intact, and so they document that the seals were intact, they were fixed, and they would also document the number of seals. So when the parcel or the sample package is opened, the laboratory uses a checklist to ensure that all the details of the parcel are captured. In current times, the opening of the parcel or receiving of the parcel is carried out under CCTV. But yet we do maintain all the details of the parcel, including the condition of the cover of the parcel, the condition of the contents inside the parcel, how many samples came, name of the sample, and what was the name of the sample on the sample container. And then you carry out a documentation on opening the parcel also, and all this is carried out not by a single food analyst, but in the presence of a second person as a witness. So why is this so stringent? This is again to maintain the accountability or to see that the sample which is sent for analysis is not tampered with. It is just like having a bottled water or something which says do not use if the seal is broken. So here also, this is, we do not have that type of stringency, but we try to take care of any attempts that can be made to tamper the parcel. So now, when the food sample comes to the laboratory, whether it is the referral food laboratory or the regulatory laboratory, documentation is the first step, as we have seen. And on seeing the, after documenting, the parcel is opened and it is observed to find out whether the sample is fit for analysis. If the sample is fit for analysis, it is sent to the concerned section of the laboratory for carrying out the analysis. If the sample is broken, or if it is putrid, smelling, or any fungal growth or untoward observation is noticed, the sample can be sent back to the food safety officer or the designated officer within 7 days of receiving the sample. And when sending back also, they cannot just send it back. The reason for it being unfit for sample analysis is mentioned, and it has to be, the reasons, everything has to be given in a particular form and format which is provided by which is provided in the food safety and standards rules and regulations. If the sample is fit for analysis, analysis is carried out, and the time given for the food analyst to carry out the analysis and send the report to the food safety officer, to the designated officer, is 14 days. So FSSAI also lays down time limit. So it is not that a sample comes and lies in the laboratories without being analyzed. So we have 7 days to tell the officer that it is unfit for analysis, and you have 14 days to carry out the analysis. For imported samples, it is expected that the analysis is completed within 5 days, except for the microbiology. Those of you who are microbiologists will know that you cannot complete the analysis within 5 days. So in case a sample container received in the laboratory is in a broken condition or unfit for analysis, he shall, within a period of 7 days from the date of receipt, inform the DO. In case the samples cannot be analyzed within 14 days of receipt of the sample, the laboratory can inform the designated officer and the Commissioner of Food Safety, giving reasons for why it cannot be analyzed. Sometimes the instruments may be down, they may be up for maintenance, analysis cannot be completed, and sometimes the load of analysis also is very high, and analysis cannot be taken up, because irrespective of the number of samples, all the tests must be done. So what type of tests do these laboratories do? They do general parameters such as moisture, total ash, acidity, total solubles. They test for the what is given on the nutritional panel to see whether it is the truth or not. You test for food additives and contaminants, and microbiology testing is carried out. They can be in different sections. And all the analyses are carried out as per checking the labeling, checking the packaging, carrying out the analysis for standards, that's the contaminants, etc., looking at the prohibition and restriction on sales, and for contaminants, toxins, and residues. So labeling, you have seen this. So you have a checklist and find out whether the labeling for a packaged food, it meets our rules and regulations. The analytical methods that are to be used by the laboratory are normally FSSAI has made manuals for almost all the commodities, or you can use BIS methods, or you can use the AOAC, that is the Association of the Analytical Community Test method. This is an international method. For microbiology, they can use the USFDA, the BAM, or the AFA, which is the American Public Health Association compendium, and the analysis has to be carried out. But what is important in doing analysis is to use the fit for purpose methods. What is fit for purpose? A fit for purpose is to do a test for the purpose of that particular analysis. What you see here is if a sample is to be analyzed for mercury in packaged drinking water, we know the limit is 1 ppm, 1 microgram per liter. Thus, the method that you use should be able to perform the analysis with the LOD, the limit of detection, at less than 1 microgram per liter. You cannot use a method where the LOD is 10 micrograms per liter, because you will not be able to read anything or analyze, get results for anything below 10. So this is a fit for purpose. So you have to see what is the limit, and you have to see what is the LOD or the LOQ of the method that you are using. In contrary to this, if you're doing a moisture analysis, say of an atta sample, the regulation says the moisture should not exceed 14%. So your method need not go down to the microgram level. Your method can be at a level of the nearest of 0.1%. So this is what fit for purpose is. And there are several food testing methods. And now in this AOAC series on e-learning, I am sure you have all been exposed to all these methods: chromatography, LCMS, MS, atomic absorption spectroscopy, induction coupled plasma mass spectroscopy, isotopic ratio mass spec, immunoassay, ELISA, UV visible, metabolomics, microscopy, Raman spectroscopy, and all. So any of these methods can be used. So the toolbox is very heavy for food testing. So the laboratories that are carrying out the analysis, that is the regulatory laboratories, they must apply all the international standards. So they must get a third-party accreditation. Medical laboratories have 15189. If you are a proficiency testing provider, you take the third-party accreditation for 1703. You use the ISO methods for statistics. You use good laboratory practice, the OECD principles. For reference materials, you follow the guide. So you can follow all the ISO, the international standards, which are applicable to the laboratory. All the laboratories will have quality assurance and quality control. We have gone through this. So essentially, they must use reagent blanks, verified standard solutions, check the samples, blind samples, replicate analysis, and have control charts. And they must use certified reference materials or the NIST standards to check the performance of their samples. There could be internal quality control samples, or there could be certified reference materials, or you could use the samples which are supplied for proficiency testing. So what is important is that the laboratory follows all the regimen of quality assurance and quality control. Then, so this is what the laboratory is expected to do. So if the laboratory is doing its job, then we know that the test can be submitted. But the most important part of testing is sampling. If you do not take the sample correctly, then your analysis result or analytical result will not represent the sample which has arrived in the laboratory. So therefore, in any analytical procedure, sampling is very important. So what is sampling? It is a process for making an inference or a decision from the analytical data by multiple mass reduction stages from a decision unit or a sampling target. What this means is if you get a sack of wheat atta and you do the analysis from say 10 grams of sample to 10-gram aliquots of the sample, those two 10-gram aliquots must be representative of the whole 100 grams of atta in the box. So it should represent the sample. It cannot be just from the top of the bag or from the bottom of the bag. So that is what sampling is. So if you look at a measurement process, this is the process of sampling is very important, both from when sampling takes place in the field to sampling which takes place in the laboratory. So all the sampling methods are statistically controlled to see that you get the representative sample. So what is shown in shaded here is what the food safety officer is expected to do. So because he is the one who collects the sample from the field, that means from the food business operator, and that he breaks it down into a primary sample, a subsample, and sends a lab sample to the laboratory. Now the laboratory will receive the lab sample, and the laboratory now will reduce that lab sample will reduce. It could be 500 grams, it could be a kilogram. They must reduce it to the test portion. This test portion must represent the lab sample that you received, and that lab sample represents the sampling target. So sampling is very, very important, and we have procedures. Codex has laid down some analytical, some sampling procedures which are all based on the statistics. It is like a survey being done across India. So unless the survey is done properly and unless the sampling plan is there, whatever results are the outcome, it will not represent the whole of India, but may only represent a pocket. So in any sampling process, it should represent the whole lot. So if we are talking about something in India, it represents the whole of India. So the whole of India becomes the sampling target. So sampling is very important. So the error in any analytical procedure, you will see that the major error comes from sampling. 70% of the error comes from sampling, and only 30% comes from what you carry out, the analysis that you carry out. So therefore, it is very essential to take the correct sample, means sample the lot. So terms that are used in sampling are decision unit, that is the unit on which the decision is made. It could be a bag of coffee beans. It could be a sack of rice, it could be a ton of material in a truck, or it could be 5,000 liters of milk in a milk truck. It could be 20,000 bags of wheat in a ship. So that is the decision unit. Increment is defined as an individual portion of material which is collected by a single operation using a sampling tool or by using combined with other increments. So as we go on, I will show you the example of increments. Primary sample is the collection of one or more increments which is taken from the decision unit. So if it is a ship, if 10 bags are taken, all the 10 bags are pooled, and that is the primary sample. If you go into a shop and there are 2 cases of biscuits, and from the 2 cases you pick up 4 or 5, they are mixed. The 2 cases mixed form the primary sample. The laboratory sample is what comes to the laboratory. It could be 50 grams, it could be 500 grams, it could be 4 liters of water. Analytical sample is the sample that you take in the test tube or you put into the moisture dish to carry out the analysis. And the test portion is the portion that you use to take the measurement. So sampling in the laboratory, we will not look at sampling that takes place outside by the food safety officer, but we will see how the laboratory is involved in sampling. So the laboratory is involved in a smaller scale of sampling process. Each time it selects a smaller mass from a larger mass, what we would call as mass reduction. So you receive the laboratory sample. So there a physical preparation is carried out. It could be drying, sieving, milling, or homogenizing. And then you take a test sample. And from the test sample, you take a test portion. The test portion you take and you do chemistry. Either you put it into the oven, or you put concentrated sulfuric acid, or you add hexane and put it for fat extraction, or concentrated sulfuric acid for digestion to do the gel dot. The digest that you get is the test solution. You know, you're going to do the steam distillation, and then you're going to take an aliquot and do a titration. So final titration is what gives you the analyte concentration. So if you make any mistakes here, you know that this value that you have got will be wrong. So we must ensure that no mistakes are created when we do what is called as a mass reduction. So errors that are linked to the analysis in the laboratory are a characteristic of the material being analyzed. 2 types of characteristics which contribute to sampling error are: one is compositional heterogeneity or constitutional heterogeneity, and the other one is distributional or spatial and temporal heterogeneity. The names itself tell you compositional heterogeneity means the composition. That means it could be a mixture of A, B, C, D. And distribution is, it could be a sample A, but the distribution, you know, because of its weight, could be distributed unevenly. So what is compositional heterogeneity? So compositional heterogeneity is like this bowl of trail mix. It contains nuts, it contains Smarties, it contains raisins and some dried fruit. So here you have got a compositional heterogeneity. Now, if you are asked to analyze the color of this sample, you will not take only the colored portion of the sample, but you need to take the whole sample. So How do you get the whole sample? You can get a representative of this sample by breaking down the size or by carrying out what is a process called comminution. That means bringing down the particle size. So you grind the whole thing, and when you grind it, you have a homogeneous sample. So what is compositional heterogeneity? You see different things are distributed unevenly. Different compounds or different elements are distributed unevenly. So if you do a coarse grinding, you have less. And if you do a fine grinding, you see that you can decrease the constitutional heterogeneity. So in the laboratory, what are the examples? One of the best examples is when you're doing aflatoxin analysis, and if you get a corn on the cob like this. So look at this corn. So if I analyze only these kernels over here, I might get the absence of aflatoxin. However, if I analyze the kernels which are here, I might get 100 times or 1,000 times the value. So here the analyte is unevenly distributed in the sample or in the decision unit. So how do I reduce this compositional heterogeneity? I can take out all the kernels, infected, uninfected, and I can grind them together to a particular particle size. And when I grind it and I analyze the sample, it represents this whole cob. So that is what representative sample means. So taking 2 seeds here, or taking 2 seeds here, or taking 2 seeds here does not represent the sample. So compositional heterogeneity is a problem in sample analysis, but we can reduce the compositional heterogeneity by mixing and blending, and we can further reduce it by comminution, that means making it into smaller particles, by chopping, crushing, cutting, grinding, or any other methods, changing the physical properties of the sample. So the reduction of the average particle size is the dominating factor in reducing this constitutional or compositional heterogeneity. So what is distributional heterogeneity? Distributional heterogeneity is the heterogeneity caused by distribution in space and time. And this results because of the differences in the weight. You might have small, you must have dense fines, you might have very heavy particles. So if this is a truck of wheat going to be analyzed, what happens is as it travels, because of the gravitational forces, the heavy particles settle down and the light particles remain on top. So if I analyze only this portion, I am not analyzing the representative sample. Also in a silo, if you see, this is what happens. So this type of heterogeneity is known as distributional heterogeneity, and the error that comes from this type of heterogeneity is known as the grouping or segregation error because of the gravitation. That is, it is the same sample, but because of the difference in size and density, there is a separation. So how do you decrease the distributional heterogeneity? You see, you have the light on top and the heavier down. So simple blending or mixing by even using a bag will give you a more homogeneous product. You could also grind the ingredients to a uniform particle size, and incrementing will help to reduce this type of distributional heterogeneity. So in the laboratory, this is what happens. This is a type of grouping or segregation error. Whenever you get milk or milk-related samples, cream, in the laboratory, because of the shaking or action, what happens is the lighter portion of the milk, that is the cream and the fat, come to the top. So if you analyze only the top portion of the milk, you are going to have a grouping and segregation error, and it will not represent the milk which has come to the laboratory for analysis. So what must be done? So you have to carry out a mixing or blending or a homogenizing, and what you get is a homogeneous sample where the segregation error is reduced. So now if you analyze this mixed homogenized milk sample, you know that what you are analyzing is representing the material that has come to the laboratory. So how do we reduce both these types of errors? One is by coarse grinding, or what we call as pre-grinding, either using a mill or chopping the particle sizes, and before we try to do the mass reduction or the sub-sampling. So you could use mixing techniques. Many laboratories use the mixing techniques to homogenize the sample. For liquid samples and things, you could use a homogenizer or a blender to homogenize it, and you can carry out the mixing. Unmixable mixing techniques such as these, where if you get a tin of baby food to analyze, you just take the top portion, and by stirring the top portion a few times. For dry ground material, shaking a sample container when the jar is full or almost completely filled is an unacceptable mixing technique. At least 30% of the tin should be empty if you want to use the to mix the sample to homogenize it in the tin. The material at the bottom of the container is not properly mixed, and stirring might have actually promoted its segregation. As I said, you should leave at least 1/3 open space if you want to do the mixing in a container. But the best method would be to put it into a homogenizer and just homogenize it so that it homogenizes. So you empty the whole container into this and homogenize it. Simple mixing techniques that can be used in the lab are by using the Ziploc bags. So you can half fill it with the sample and invert it as shown over here. And so what you finally get is a homogenized sample. So next you have the error. Next type, the first type of error is this segregation error that is due to heterogeneity of the sample. The next error in the laboratory that is very common is when we split the sample. So if we have got a 500-gram sample and we want to analyze it and we use only 5 grams, how do we split the sample to show that the sample we take is representative of that 500 grams? So the laboratory process is known as mass reduction. That is the common process. So the way in which subsampling is achieved is also a source of possible errors. So the sampling errors due to subsampling can be divided into what is known as delineation error, the extraction error, and the preparation error. So we will see the extraction errors and the preparation errors lie with the analysts, the way they do the sample extraction and the sample preparation. We will look at the errors which are contributed by delineation. So what is the delineation? You have the sample, you have emptied it out onto a clean sheet of paper, you have made it into a 3-dimensional pile, and now you want to sample it. If you take the sample, what is shown over here and here, These are delineation errors. So what happens in this case is this portion and this portion are excluded from the sample increment. So here also this portion and this portion is excluded. What is required for you in the mass reduction is to take a sample right to the end. So this is the correct delineation, means the sample reduction. So why does this error occur? This error occurs because we use the wrong tools for sampling. So the extraction is done incorrectly because of the extraction tools. So the extraction tool that has been used is a round-edged shovel. If you use a square-edged shovel, that is as shown here for sampling, even in the laboratory when you take for weighing, it is always better to use the square-edged spatulas or two when you're trying to reduce the sample. So you see, when you use these round-edged shovels or the spatulas to take the sample, what you have is these types. So when you have a round edge, it misses this portion. When you have a square edge, it takes this portion. So in another mass reduction, when you get a sample which is a heterogeneous material of a single product, such as this as fish, or maybe it is coffee seeds, or it could be a bottle of pickle. So how do you take the sample for analysis? Because you cannot do a pile, you cannot pour it onto a sheet of paper and pile it. So sample by sample, you decide on how to do the sampling. So if you get this type of fish for analysis, the best way to do the analysis is to grind it in a blender with the skin and the bones. And when you grind it, what you take over here, if you take a sample, if you take 5 grams of the sample here, or you take 5 grams of the sample from this portion of the blender jar, it represents the whole sample which has come to the laboratory. And in the laboratory, it is very simple, especially in the regulatory laboratories, because the sample sizes we get do not exceed more than 500 grams to a kilogram. So you can homogenize the whole sample or blend the whole sample. And now when you blend it, you will not have any sampling error and you need not have any delineation errors. So you can take the sample from anywhere in the blender. So where do we see this type of thing in the laboratory, especially when you get a jam or you get pickle? In the pickles, you will see the oil is on top. You have different pieces, different sizes of lime or mango cut. And so if you have to do the analysis for sodium chloride or sodium, how do we get a representative sample of the whole product? So if you're doing the analysis of biscuits, very often you will find that people just take the packet and analyze 2 or 3 biscuits. That is the wrong method of analysis. You need to subsample it. So the best way of sampling these type of products is to empty it into a blender, powder the whole product, and from the powder, now what you see in the blender over here, whether you take it from this corner or this corner, you will have the correct sample size and it represents this biscuit packet. So the technique or the secret of avoiding sampling errors is to grind it to a uniform particle size for all the other procedures to be carried out. Subsampling, when you have large amounts of grain or maybe say atta sample coming to you, many sophisticated laboratories use what are called as the splitters. These are equipment that are available and they can carry out the splitting of the sample uniformly, and they can be either a rotary splitter as seen over here. So the sample is fed into this rotor. The rotor is attached to 6 or 8 bottles, and as the rotor spins, sample will flow into these bottles. So now all the 8 bottles, if you analyze all the 8 bottles, you should get the same value because each bottle is a representative of what has arrived. You can have rotary splitters which are of this type. You feed the sample here and this rotates. So here is the sample feed and it gets filled into these cups. You also have what are known as riffle splitters, where it is the sample is this shakes mechanically and the sample is fed into this and the sample gets divided into 2. Now whether you analyze this sample or you analyze this sample, it represents the original sample. You could also do coning and quartering, which most of the laboratories do, is to first pile the sample, then flatten it out so that you have an even height and make it into a circle, and then quarter it and use the different quarters for the analysis. Now, the same coning and quartering can also be done by fractional shoveling. You don't need the expensive equipment like this. The same can be carried out as shown very simply without any equipment. So if you have a laboratory sample, you can use a scoop and scoop it into 3 fractions, what we call as shoveling. So we take a shovel, fill it and put it into fraction 1. Take another fraction and put it into a second place, and a third into a third container. Now F4 will be taken and put into F1. F5 goes into F2 and the 6th portion goes into F3. So this process is continued unless this pile is empty. And then these are mixed by using a mixing bag technique or by using the blender. Now the 3 samples are representative of the original laboratory sample. You can divide it into either 3 fractions or 5 fractions or 10 fractions or whatever number you want, but the minimum is 3 fractions. So you could also do it into 5. So you have 1, 2, 3, 4, 5, and then 6 goes into 1, 7 goes into 2, and 8 goes into 3. So the number of fractions that you make, you split it, is up to you. Sometimes in laboratories, they are divided into, say, 4 samples, and they're given to 4 different analysts to see the quality assurance and the quality control. You could also do mass reductions by the spooning method, by laying out into a uniform layer, then mixing it in so that the sample is mixed, as you see here, the S-shaped pattern for spreading the laboratory sample in a tray, and B thing is the random spread location of the extracted increment. So now you can spread it and you can collect these samples, or you can use the spooning method. So whenever you're doing sampling, whether you're using a homogenizer or you're using a mechanical splitter or the coning method or thing, you must make sure that nothing happens to the analyte. So the analyte must not be destroyed. So oxidation reduction can occur, microbial viability may change, some volatiles may escape if it has heated too much, moisture content also can be. So you have to look at the integrity of what is the stability of the analyte when you're carrying out these procedures. So let's come to the last part of it, which is microbiology testing and how do we do sample in microbiology testing. Doing the microbiology sampling is one of the poorly understood parts of food microbiology. There are different types of microbiology testing. You know, we do testing for safety, that is doing the testing for pathogenic organisms, and we do the testing for process control or for the hygiene, that is the food hygiene. And I'm sure in the microbiology webinars, the distinctions would have been made very clear to you. Microbiology testing is also done for investigation whenever there is a breakout, and also for surveillance to fix the limits. But sampling is very important in microbiology because the microbes do not distribute themselves uniformly in a food. That means when a food is there, the microbes don't talk to each other and say, I will grow here, you grow there also. So they are randomly distributed in the food. So when you take a sample, it must be representative, just like what you saw in the aflatoxin analysis. So when the microorganisms are distributed in the field, in the food, what you see is some of them may die, some are unable to grow, and others will find themselves in an environment or a conducive environment they can multiply very fast. So the resulting distribution containing aggregates of cells is called a contiguous distribution, as you will see. So microorganisms, you see the distribution of microorganisms. They are very irregular, they are random. Okay, so sometimes they may be regular, distributed evenly, and sometimes you see these are very happy because the environment is conducive to them for them to grow. These which are individual are half-heartedly growing, and there are some areas where probably the microorganism is dead. So this is the spatial distribution of microorganisms in food. So now when I test the microorganisms in food, I have to have a representative of the whole. I cannot analyze only this portion and say the microorganism was absent, especially when it is a pathogenic microorganism. So sampling is very important here, and it differs from the sampling for chemical analysis. So the spatial distribution of the microorganisms in food can be compared to the spatial distribution of the chemicals and toxins, such as the aflatoxin in the commodities. So the food safety and standards rules have defined the sampling methods in microbiology. If you go to Appendix B, where the tables 1 to 7 tell you what are the microbiology limits, the parameters, and what microbes have to be tested for. At the bottom of this, each table, you have a table A for food hygiene and table B for pathogenic organisms. At the bottom of each table, you will see the sampling plan. So what is the sampling plan and what do those numbers mean in the sampling plan? So in the sampling plan, the following elements are described. The microbe or group of microbes. So here they are grouped into the hygiene and into the pathogens. It gives you a number n, which tells you the number of samples to be tested. This n is not the duplicates that you do, but it is the number of samples to be tested. So if I am testing pickle, I must test If n is equal to 3, I must test 3 bottles of pickle. If n is equal to 60, as in the baby food or the infant food, I must test 60 tins of baby food, not 60 samples. The test methods are also indicated, and you have limits which are given as small m and capital M. So those of you who have been wondering what is the small m and capital M, when the limit of the microbes is less than small m or lowercase m, it is satisfactory. If it is greater than capital M, it is unsatisfactory. And we have a limit if it is between small m and capital M, it is called acceptable, and the food business operator is actually informed to improve the process of hygiene. So these are 3 attributes, that is satisfactory, acceptable, and unsatisfactory, and the number of samples C which fall into each of these categories is also given. So just let us understand that. So there are 2 types of plans. One is called the 2-class attributes plan, and the other is the 3-class attributes plan. In the 2-class attribute plan, there are only 2 classes. One is either you accept or it is unacceptable and therefore rejected. So in the 2-class plans, when you have small m, capital M, and the 2-class plan, if n samples are tested and all the samples, the results are below small m, the results are acceptable, the food is safe. Also, if C is given, in many cases a C value is given. If C of the n samples are greater than m, then you can accept the lot. If greater than C of the n samples are greater than m, it is rejected. So that is how you interpret these C values, C, N, and M in the 2-class attribute plan. It's called a 2-class attribute plan because it's either acceptable or unacceptable. So we accept the lot or you reject the lot. And this is the plan that is generally used for pathogenic organisms. So either you accept or you reject it. When you do Salmonella, Shigella, E. coli, Vibrio, Clostridium analysis, it's either accepted or rejected. There is nothing in between. Now we go to the 3-class plan. In the 3-class plan, you have 3 classes. One is acceptable, the other is unacceptable, and we have a 3rd class which is between the 2, and it is marginal, and it could be acceptable by changing the conditions of hygiene. And this 3-class attribute plan is usually for the hygiene organisms such as the total plate count, the coliforms, etc. So here again, just like the 2-class attribute plan, small m and capital M are set, and the limits are m. It commonly reflects the upper limit of good manufacturing practice, and the criteria capital M marks the limit beyond which the level of contamination is hazardous or unacceptable. So what you can see in red is here inacceptable, you will not see it. In unacceptable, there were too many of them, and marginal is there are very few which are not of a health concern. And the 3-class attribute plan is generally there for the food hygiene microorganisms, as I said, which include total plate count, coliforms, yeast and mold, etc. Not the pathogens which are there. So in the 3-class attribute plan, when the limits have been set for M and the C values are given, If all the samples fall below M, no problem. It is acceptable and it's satisfactory. If less than C of the N samples are within M, say it is given C is equal to 3 out of 5 samples. If 2 of the samples have higher limits and 3 of the samples have lower limits, it is still acceptable. So if it is less than C of N samples are within greater than M and less than capital M, it is acceptable. Now, if greater than C, if N is equal to 5 and you find that 4 out of the 5 samples have got limits greater than M and less than M, it is unacceptable. If any of the sample is greater than M, also it is unsatisfactory. So the leverage is given only when the C value is given. So what is the choice of the sampling plan? The choice of the sampling plan is whenever you have absence or presence, such as the pathogenic organisms, where it says absent in 25 grams or absent in 1 gram or thing, we use the 2-class attribute. And in the case of the quality indicator organisms where the hygiene is of concern, that is the total aerobic plate count, enterobacteria, coliforms, yeast-and mold, Campylobacter, Clostridium, because these are mainly the hygiene parameters, then the 3-class attribute plan is used. So in the 2-class attribute plan, you see it is accept presence of this organism in the food if C is greater than 0 or C is equal to 0. So let us look at just 2 examples before I close the microbiology analysis of fish and fisheries products. So there are 16 food product categories under the fish, and the process hygiene criteria given is aerobic plate count, coagulase positive, yeast and mold count, and it says after chilling or freezing. So the microbiology safety indicators are E. coli, Salmonella, Vibrio, Listeria, Clostridium. So what is the sampling plan? For this, for the fish samples, you need to analyze 5 different samples. And when it says C is equal to 0, all the 5 samples must show below capital M. Okay. And then you have for milk and milk products, you also have hygiene parameters, which are coliform, yeast, and thing. And you have the safety parameters, which are E. coli, Salmonella, Listeria, Bacillus, Sulfite, and Enterobacter, Sakazaki, or this is the Chronobacter, the only food in which this microorganism has to be tested is the baby food. So if you look at the infant formula, when you have to test for Enterobacter Sakazaki only for the infant food, you see you have to analyze 30 samples, and in the 30 samples, the value M is given, which is absent in 10 grams. So in all the 30 samples, it must be absent in 10 grams. Even in one sample, if you see 1 CFU in 10 grams, this becomes unsafe. So this is how you interpret it. C is equal to 0. So all the 30 must show absence of 10 grams. For Salmonella, 60 samples must be analyzed. The M value is absent in 25 grams, very stringent. And all the 60 samples should show absence in 25 grams. For Listeria, N is the 10 samples have to be analyzed, C is equal to 0, and it should be absent in 25 grams. So also for the follow-up formula, the Salmonella has to be done, N is equal to 15 and C is equal to 0. So microbiology sampling is entirely different from chemical sampling, and I hope those of you who are microbiologists are doing the analysis this, and you understand what is N, what is C, and what is capital M and small m in the microbiology parameters, which is given in Appendix B of the Food Safety and Standards Rules and Regulations of India. And finally, the reports have to be written after doing the analysis. The forms are there. You have Form A and Form B. This is for the referral food laboratory. All the details are given, and it has to be written only in this format, not in the format or any format that you have. So this includes sample description, physical appearance, the label. It also tells you the characteristics. You have to write the name of the method and the test, the results, and you have to say what is the limit in the FSSA rules and regulations. In addition to this, your responsibility as a food analyst is to write an opinion. So what is this opinion that you write? You have to state whether the food is safe, unsafe, or misbranded, or it is substandard. So let's look at one example. This is a sample of pasteurized milk, and if you look at the thing, the milk fat is less than what is set by FSSAI, and the milk solids fat is also less than that. So what is your opinion? This is a quality parameter, and it is less. So obviously it is substandard. So you write the opinion that it is substandard and does not conform to the standards laid down for milk, because the milk fat falls below the minimum standard limit and the milk solids not fat falls below the minimum standard limit. So here are some statements where, which will tell you whether to use safe, unsafe, substandard. So when cream has not been prepared exclusively for milk, which contains less than 25% of milk fat, it is considered substandard. If the milk contains added water, it is unsafe. If skimmed milk is sold as milk, it is substandard. If 2 or more edible oils are sold as edible oil and not as blended oil, it is misbranded. If turmeric contains any foreign substance such as other starch or lead chromate, it is unsafe. If you mix coffee powder with any other substance other than chicory, it is unsafe. Dahi or curd not prepared from pasteurized sterilized milk is unsafe. Presence of kesari dal and its product is unsafe. We have the restriction on sale. Pepper raisins coated with mineral oil is unsafe. If you recollect, no food is allowed to be coated with mineral oil. If the ash content exceeds the limit, it is unsafe. If packaged drink is sold without ISI, it is unsafe. If color is detected in tea leaves, it is unsafe. So you have to be thorough with the regulation and also know some of the properties of the material to be able to give the opinion. So tomorrow will be the last webinar on the syllabus of the for the food analyst exam, and that is on the international regulations, which forms a very minor part of the syllabus on food laws.